Hello everyone, good morning. Today we will see sequence impedances and networks of three-phase transformers. Now we have seen in the first lecture of the sequence impedances and network. So there we have considered a three-phase symmetrical system and we have derived the equation for VA0, VA1 and VA2 values. There we got VA0 is equal to Z plus 3 Zn times of IA0 and VA1 is equal to Z times of IA1 and VA2 is equal to Z times of IA2. If you observe these equations, in the positive sequence and the negative sequence, we got the same impedance value. Therefore, the positive sequence impedance is equal to negative sequence impedance in static symmetrical system. What is meant by a static symmetrical system? So in power system we have the major components synchronous machines, transformers and we have transmission lines. So out of this, what are the static machines and what are the rotating machines? Means anybody can tell all the synchronous machines or the rotating machines. Since we will have a rotor in this, and transformer is a static device because there won't be any moving parts in the transformer. Similarly, the transmission line is also a static device. In the transformers and transmission lines, the positive sequence impedance is equal to negative sequence impedance. All the time this condition will be true. Now let us represent what are the sequence impedances for the transformers. We have seen, since the transformer is a static device, the positive sequence impedance is equal to negative sequence impedance, that is equal to the leakage reactance of the transformer. So whatever the leakage reactance exists in the transformer, that can be directly considered as a positive and the negative sequence reactance. Then what about the zero sequence reactance of the transformer? So zero sequence reactance can be represented with respect to two different conditions. So case 1, if there is any path for the zero sequence currents, then the zero sequence impedance is equal to positive sequence impedance or the negative sequence impedance. Second case is, if there is no path for the zero sequence currents, that condition, the zero sequence impedance will be equal to the infinity. You can understand this point. There is no path for the current. It is a simple basic condition, that is, current doesn't have any path, means that is a open circuit. Under open circuit condition, the impedance will be always infinite. Now let us draw the sequence networks for the positive, negative and the zero sequence. For the positive sequence, the circuit will have only the positive sequence impedance. Let us take this line as a reference line and the current flowing through the circuit is IA0. So what is the value of the Z1? Z1 is nothing but leakage reactance of the transformer. Now coming to the negative sequence network, this is as simple as the positive sequence. In place of positive sequence impedance, you will just represent the negative sequence impedance. This is the reference line IA2 and this is also equal to the leakage reactance. Now coming to the zero sequence network, we cannot consider as it is this network as a zero sequence network. So we need to do some modifications for some representations for this zero sequence network depending upon the connections of the transformer. So what is meant by the connections of the transformer? We know any three-phase system can be represented in two different ways. One is a star or the delta connection. In the zero sequence network, this Z0 exists when there is a path for the zero sequence currents. So whether we should put this value into the network or we should not consider this value into the network depends on these connections. So there are few points we need to discuss before representing the zero sequence network with respect to the connections. Let us have a look what are the modifications that we need to do for this network. Now we have two conditions. One is the star, another one is the delta connection. When the zero sequence currents will flow in the star connection, when the zero sequence currents will flow in the delta connection, let us have a look. We know that in the star connected system, the line currents will be equal to the phase currents. Now let us say these are the line currents. Whenever the neutral is connected to the grounded, that means zero sequence currents will enter into the star connection if the neutral connected to the ground. So that means that will have a path to flow in the circuit. Otherwise it will not have a path in the circuit. That means you should give two conditions. One is the current will enter, current will not enter. You should have a switch. If the neutral is grounded, current will flow in the system. If the neutral is ungrounded, the switch should be remains open because there is no entry for the zero sequence currents in the star connection. If it is a delta connection, everybody know that it is a direct relation. Since a delta connection doesn't have any neutral line, wherever the neutral connection is not there, the zero sequence currents cannot flow into the lines. In the legs of the delta connection, will be there any circulating zero sequence currents means? Yes, because of the zero sequence component of the voltages, there will be some zero sequence currents. That means if there is a delta connection, so within the circuit the zero sequence currents will be flowing, but to the main lines there won't be any zero sequence currents. What is that mean? In the delta connection, within the circuit should flow means we should put some switches at the shunt side. So these are the two important points related to the zero sequence component network representation. So now according to that we will do some modification to this zero sequence component. So what are the modifications means? We will put the series switches and we will put the shunt switches on either side of the transformer. Okay. These shunt switches we have provided to represent with respect to the delta connections, and these series switches we have provided to represent with respect to the series connection. Let us conclude the points. Let us consider this as a ZG0, as however I have represented in the synchronous generator to differentiate between the actual Z0, that is a combination of ZG0 plus 3Zn. So instead of Z0 I have represented ZG0. Now let us draw the reference line here. Now we have a two different conditions. What are the conditions? Two series switches will be there and the two shunt switches will be connected, right? When the series switch should be closed, when the shunt switch should be closed, there are only 2 points. First one, the series switch should be closed if the winding connection is star grounded. Star grounded in the sense, it can be star solidly grounded or it can be star reactance grounded. These two switches refers to the primary side of the transformer and these two switches are referred to the secondary side of the transformer. So if this connection exists at the primary side, the primary series switch will be closed. If this connection exists at the secondary side, the secondary switch should be closed. This is the first point. Second point is shunt switch should be closed if the connection is a delta connection. That's it. If the primary is a delta connection, close the shunt switch. If the secondary is a delta connection, then close the shunt switch of that side. That's it. So you can represent the zero sequence networks. Now let us see few examples of the zero sequence network for the different connections of the transformer. Let us take the star-star representation. With respect to the reactances, you can represent like this. So this refers to the primary and this refers to the secondary side. The zero sequence component we know. This is represented by ZG0 and the generalized network will have a two switches, two series switches and two shunt switches. Only this much you should remember and 2 points you have to remember. What are the 2 points? If it is a star neutral grounded, the series switch will be closed, and if it is a delta connected, shunt switch should be closed. Otherwise, remaining all switches will be left open as it is. Now look at here, it is a star, neutral is not grounded, so there won't be any change in the circuit. So it will be as it is. You will represent the series, both the series switches should be open. That's it, and both the shunt switches will be open. Second connection, star and delta connection. So let us draw with respect to the reactances, this is the star connection and the delta representation. If you take the generalized zero sequence network, series switches and 2 shunt switches will be there. What is the resultant network for this? It is a star connection but it is ungrounded. So the series switch will be opened as it is, and this value is, here it is ZG0. Let us consider ZG0 value, and this side also the series switch will be opened. Secondary side we have a delta connection. So delta connection means the secondary side shunt switch will be closed. So that's it. This is the zero sequence network of the star delta connection. Now the third connection, let us consider delta and star with solidly grounded. You can represent the reactance diagram only in the branches of the delta and star if you place. So the reactance diagram will be formed. So now what is the zero sequence network? The Z0. Now you can represent it directly. You no need to draw no need of this generalized circuit also. So delta connection means the primary short circuited and it is the star neutral grounded, solidly grounded. Then this side, secondary side, the series switch closed, and this side the series switch will be opened only. It is not closed. This side the series switch will be left open because it is a delta connection this side. Right? Now next one is fourth point. If you consider this side as a star connection and this side as a star with reactance grounded. Let us take the impedance of Zn here. Now this can be represented by a star connection ungrounded, and this is star connection with the neutral grounded through a reactor, so which is having impedance Zn. Then what will be the circuit here means, along with this Z0, we need to add one more impedance. That is, what is that impedance? With respect to the zero sequence current, we have an impedance of 3Zn because the neutral current IN is equal to 3 times of IA0 into Z0. So now this is a star ungrounded system. So the series switch will be left open, and this side it is a star grounded through a reactance. Reactance we have connected, and the series switch will be closed because the neutral is grounded. That's it. The 2 shunt switches will be open. So in this fashion, whatever the connections of the windings, the primary and the secondary, whether it is a star or the delta connection, star with grounded through any solid or reactance grounded, any pattern of the transformers, the zero sequence network can be formed. So I hope it is clear. Thank you.